Hello, everybody. Well, welcome for the talk. I'm very happy to be here at Pygrunn and also to talk to fellow developers. It's for a change for me. And I always start my talks about with a kind of a fact that motivates us to work in AI. The one for this week will be a study that comes from the Maître Institute, is an institute connected to Berkeley, where they look at the complexity and evolution of complexity of LLMs. And basically, in this study, what they say is if we continue, if you believe that we are going to continue in this development of LLMs in the same speed, by 2030, we are going to have LLMs that are able to, with a certain reliability, to solve problems in the level complexity of a month, like that a human takes a month to solve. And that is not the time that the LLM is going to take, but how complex it is, the task, and that takes times for humans to do that. Another aspect of that is that it's not one specific task, but tasks that are spread around a huge amount of spectrum of possibilities. This is a lot of power, but this power is at the moment in the hands of the big techs, and in a scenario, a geopolitical scenario that is shifting quite fast and gets a lot of uncertainty, especially for us starting companies investing in this new technology. There are more problems than only that. These kind of models, they have all kind of infringements of privacy, data, IP. They are not really transparent in how they operate, what they did, what kind of data they used. And they are also not tracking really how to make these development technology sustainable and fair. In a certain way, that it all touches the point about sovereignty, and there is a growing interest of the European Union and of course also from the Netherlands to invest in alternatives to the big tech. That is actually the drive that we have for GPT-NL. GPT-NL is a project where we try to create an LLM from the scratch for the Dutch society, for you guys, and create a community about that. It's not only about the model, it's about the knowledge that we want also to share about that. So our targets in the beginning were using about 450 billion text tokens, about 150 billion code tokens. What it really became, I'm going to show you during the presentation, and completely legal, or actually as transparent as possible, no IP infringements and things like that. Can we do that? That was the question we had 2 years ago. No, yeah, 2 years ago. And we targeted that for a performance comparable to Llama 2 and GPT-3, quite reasonable at the time. 2 years later, it's a bit different. I'm very happy, and we got to there, but we are beyond that. And of course, not a GPT-5, but we are beyond that. Welcome to the talk. My name is Julio Oliveira. I am the lead system architect for the project. And I'm going to present together with my colleague Athanasios. Trantas. Athanasios is one of the model developers and also a lot involved in the training. And because we are here in a community of common developers, the insight that I'm going to give in this talk is a lot of technical aspects that we had to kind of make decisions and look at the project. I will start a bit with the generic. What is GPT-NL? GPT-NL is a project with the goal of creating a fair and, let's say, aligned LLM. It's a cooperation between TNO, SURF, which provides actually the computing power behind it, and NFE, which gives us two things. The one is a good use case because they have a lot of data that cannot get out of the NFE. It's quite secretive. It's law data that cannot go out, and they need they cannot rely on models from outside. They cannot get their data out. And the second thing, they are an independent evaluator of our efforts. They are going to look and see how good we are. The values that we really try to get out of this effort is sovereignty, which kind of like motivate sovereignty for the Netherlands and also for Europe. We fight for a model that is trustworthy, where there is also reciprocity. What we mean by that is that we also give back to people that give us data some kind of things back. And transparency, we try to log and catalog everything we do, and this will be open for everybody, for the academic research community, but also for developers. And what are we targeting? We are, just to compare here more or less, we are not targeting for the almost general, very big models. We have also a very different price tag. This is actually $192 million is actually how much Google spent only in computing. 13 million is everything that we had for everything around that, also acquiring data. And but we really strive to have a base model that can be fine-tuned for and useful for different Dutch critical sectors. We built that with the AI Act in mind, and yeah, we decline for using untrustworthy sources. For whom we do that? For you, for the community of developers of the Netherlands, of Europe, and in all kind of sectors. I am going to dive a bit more now in the development, and development had in base two different phases, let's say like that are quite distinct from each other. The first one on the top is actually what we call the data curation. Is from, and we call data curation from things from acquiring data until we have a data that is ready for the training. And the second part, it is actually about the training. A bit about the data and the curation. So the data that we target for is more or less in this spectrum from completely free to completely closed. This is more or less the position of GPT-NL. And everything before we can get from outside the world, no problem. But we also have data on the other side, and that is given to us licensed, meaning they agree for us to use that. So there is IP, there is copyrighted material in our model, but it's given to us for this purpose. Like I said, the data curation starts with data acquisition, and if you would like to go in this direction of creating a thing from scratch with this amount of data, don't underestimate the amount of work and issues that you're going to acquire the data. It's different from scraping, it's different from going to a database and downloading it. I think we underestimated that. This was one of the lessons we learned, and we thought it would be in 3 months. We had 1.5 years to really get that right. And I will get to more about that, but basically things that you have to think about in these cases, because you want to attract people that will trust their data to you, you have to prepare, for example, good environments where they can log in and transfer their data from their bases to your base in a safe way. How to store that? What is the time that you are going to store that? How do you control that other people will not be able to see this data, leak this data, and things like that? And we didn't know that we would go so far. But of course, after that, you have like a lot of technical pipelines. We are going to extract the data from very different types of, from PDFs, from CSV files, from database, from PDFs that has only images inside. You have to write things to OCR it, you have to generate data, and so on and so on. But we put this in kind of a framework. This framework will be available as well for the community. It's open source from beginning of next year. I will come on that. Then when this data is inside, it's what we call it extracted. Then we start actually curating it. Curation, you think all kind of operations like filtering the data, normalizing the formats. We counted that we had about 27 different types of spaces. And we kind of bring it to only one type of space. And this kind of thing, we had a lot of effort on doing private information masking, for example. Who is not really known persons in the Dutch environment and in the world, they are kind of, the model doesn't know about them. That's a design choice, and that's a design choice we made. There is a lot of details in here, and I don't have the time to deep dive on it, but I really, if you are involved in work on this level and you want to talk to us, I invite you to really approach me. What is the result of this pipeline of curation? Well, it was a curated data. I highlight here actually the heavyweight contributions that we have. This data set that we call the GPT-NL corpus is formed in 3 parts. The first one is actually coming a lot from common corpus. It's the open part of the thing. But then we filtered the high quality data and also the data that was most interesting for us, like English and Dutch. Here you see, for example, we go much beyond the 150 billion that we wanted for code. We went for 232, but this is available for you if you want to do that as well. Another type of source that we had is collected data sets. They are partially open as well. You can get them, but it's a bit more, it's not really in an open Hugging Face. You have to really talk to these partners. And you see here is actually a lot of communities inside of the Netherlands with different dialects and things like that. That was a very good point. I think we don't have dialects from Groningen. It's a pity, but yeah. And the third type of data that we have is actually consented data. That is media data. It's really expensive data. We did not have to pay for that, but we had to agree with them with some kind of mechanism where they get back, not only for them, but also for all kind of producers of these data, so really the authors, some kind of monetary back. That will be very important later, because then this kind of agreement is now regulated according by a content board, where all the producers and providers of data, they make part of it, and they have some kind of saying also about what should be the usages of the model, how do we exploit that, and things like that. And that brings me to a point that I already anticipated. The question is always, will the weights be open? It's a soft yes. Yes, but you have some gates to get to the weights until you really can have it. And that is because of this. We have to kind of guarantee that the people that offer the data, they get something out of it as well. With that, I will give the word to my colleague Athanasios, who is going to talk about the training.
Yeah, thank you. Yeah, I think Julio set the scenery with presenting the data. So essentially, he talked about this part, and I'm going to talk about all the others. So, very high-level overview of what we're doing here, given the data. We need a training loop, which essentially computes gradients and losses, syncs them, does a backward pass, logs everything. So we log everything in terms of metrics of the model, how it performs, how it trains, checkpoints very frequently, and also does a validation. So while we train like classical neural networks in autoregressive setup. So we train and validate on the fly. Of course, we do some kind of evaluations offline, which I'm going to go into detail a bit later. And finally, we test the model. Of course, we do a lot of experimental analysis and testing the performance offline. So we grab some of the pre-trained weights and we test ourselves. Yeah. So some important also parts that happen after we get the data, the original data that was discussed by Julio is we need to tokenize them and version them and also store them. We sample them to create different splits, both for training and testing. And we need to copy the data of different nodes into our file system. This is more or less a bit of the higher overview of the training. The other important thing is you're aware of when we're trying to build these LLMs, we have requirements of compute. That means that we need to distribute our training. So our model should live in multiple parts and be able to train as fast as possible. There are multiple ways to do so in the literature, and the community actually is producing new methods by the day. But for our case, we went, for example, for data parallelism, where we split the model into different nodes along with their data. You can have, for example, tensor parallelism that helps you also shard the activations of the model, or also pipeline parallelism that also can split the layers of the model into different GPUs. I'm going to go into more detail into that. The framework we use per se is called Fully Shared Data Parallel, or FSDP in short, and essentially it is an upgrade of 0.3 strategy. Essentially what this framework does is partitioning the parameters, the gradients, but also the optimizer states, but not the activation memory. But with this setup, based on the size of our model, now we can fit our model into multiple GPUs, into multiple nodes. There is also a catch. There's always a catch when you're doing these things. There is a lot of overhead between GPUs. There is a communication from GPU to GPU, right? You cannot save yourself from this one. You're going to hit that eventually. But in the end, we can see that the FSDP does something, as you can see here, like the very intense communication between GPUs, but all the passes are trying to be arranged as kernels in a linear way as best as possible. Okay, so we described a bit of how we can actually train and deploy our model into a high-performant cluster. But before we even do that, we have to decide what framework are we going to use to train it. And then we had like two choices. Either we're going to go pure PyTorch, or we're going to go with Hugging Face that offers support from this speed for parallelization. I'm not going to stick a lot into the details, but PyTorch is a more raw way to express programs. It is more, you have more control over your program. Of course, it's low-level Python. It's built on C. It's super fast. But Hugging Face is essentially a wrapper, so you don't have to write a lot of code. It used PyTorch under the hood. And then we decided, okay, we need to build a setup to test these two methods, right? These are the two prominent methods. Which one is best? And how to measure that essentially is with performance metrics, how many tokens we can process, for example, per second in our specific hardware. Our model, we based our model on Llama 3 transformer architecture. It's a pretty common, very stable architecture, very powerful. These are like this thing doesn't seem to work anymore. Some configurations about the model sizes. We built two model sizes, and even one even bigger, smaller to test on, like 1 billion, so we can debug the model while we're training on it. Moving into some results of some experiments. As I told you before, we tried these two different code bases. We implemented this architecture with two different scaling frameworks. What we found out is in terms of through output in tokens, in both cases, you can see the PyTorch and the FSDP is the orange one, and the Hugging Face and Deep Speed is the blue one. So tokens per second through output, PyTorch wins. Hardware efficiency, PyTorch wins. Energy consumption, PyTorch loses by a small margin. But still, another interesting results we got from this experiment was the node scaling. So how our architecture can scale up into different number of nodes. Each node in that case contains 4 GPUs. We have in total 22 nodes. That leads to 88 GPUs in total. So as you can see here, this guy here, it's the PyTorch one. We can see better scalability from the deep speed. That led us to move forward with a solution based on PyTorch native, and we have built our core solution on top of an already strong implementation that comes from Olmo AI. AI2 is the company, which is an institute in UK. Yes, I'm gonna go a bit faster. So we use also, I have the time. For MLOps to log our project and everything, we use weight and biases to manage the whole life cycle of the model. Some lessons. Some lessons we learned. If you're gonna use these GPUs, use flash attention V3. You shard as much as possible. If you don't have a lot of nodes, you don't shard. Scaling, it's not a classical HPC problem, needs a lot of software improvements. Our colleagues from Surf were super helpful on that to get us on a good foot. And of course, you cannot do a lot of hyperparameter tuning after you have that. Data loading, yes, okay. You get the data, we bucket them, we tokenize them, and then we do the mixing by upsampling or upsampling the current data. Hyperparameters, I'm not gonna go through all of them, but an important one is like the learning rate scheduler we use here. It is based on a trapezoid concept, so we have like an annealing phase in the beginning, then we keep it constant for a lot of steps, and then we decrease it during the end. For evaluation, we do in-loop eval and out-of-loop eval. That means, as I told you before, while we train, we do evaluation, but also we do offline evaluations. We do it in 2 settings, 0-shot and 5-shot. These are some examples how it looks like. And multiple tasks, from sentiment analysis to summarization, common sense reasoning, multiple tasks we evaluate constantly all the time. This is my last slide, sorry. So, some takeaways from the complete process. This is a team effort, a team of very good and brilliant engineers in general. Very critical, as Julio said, we should not underestimate the time to get the data, curate the data, and you also need to properly tokenize them. You need to be very careful about tokenizing them properly. We should not rely on pure evaluation metrics. My graph says I'm going well, perfect. Yeah, that's not the truth in many cases. You have to handpick some examples and see how actually your model performs, like see, does that make sense what the guy is generating? Good practice to develop 2 models, one big one that you're gonna train in the end, but also a small one to experiment and debug with. Currently, what we are doing, we are fine-tuning on instructions, so the model should follow instructions, and we're also evaluating this. With that, I'm gonna pass to my colleague Julio for the rest of it.
Yeah, I would try to give an idea of the timeline on what you can get out of that, and then go to the questions. So basically, where are we? We are almost done. We are in the phase of fine-tuning the model now, making our own evaluation, and there will be an extra evaluation from outside, from NFE. But basically, in the 4th quarter, you are going to have a model that you can reach for us to use for your products or for your research. By the 2nd quarter, we want to have already feedbacks and kind of evolve that to a newest version, but it will be basically correcting and understanding a bit more. But more than that, we are in the same period delivering all the source code base that we use it for that. In terms of data creation, in terms of training, in terms of data extraction, in terms of evaluation, and so on and so on. With a lot of documentation as well, what we learned about that and what you could kind of take out of it. What you're going to get in this model is a model that, compared to other ones, at least it gets much better in knowing who published the sources on it, if you had material scraped or not, kinds of opt-in, fair data, and so on and so on. So a model that is actually prepared for complying with the AI Act and be used in products without problems. How that it goes further, so in 2026 we are going to exploit it. So we are going to de-accelerate the development and really try to connect with the community to get it then accepted and in the community. In 2027 we want to make that part of the AI factories here in Groningen as well. And yeah, 2028 we start evolving that to other kind of inputs like image and sound and so on. I would like also to thank all the team. I mean, it's a lot of people, brilliant people to work with, very happy, and they all deserve a big applause. And we are here, the rest. There are a lot of these colleagues that are also around, so please reach to us. And we are going to be here downstairs where we had the lunch, making a small demo of this development phase, so you can still see how we are performing, seeing where we still have to improve, and everybody's welcome for the demo.
All right, give a big applause.